Okay, y'all. Hopefully everyone's back. Awesome. Here's the link to the stream. Go there. Once you get there, just let me know in chat that you are there. Peter is here. Gabriel's here. Rasan's here. Skull BX20 says, what's up? Hey, Skull BX20. What's up yourself? Alright, folks are leaving. Yesenia's here. I'm gonna go ahead and close out a Blackboard. Okay. Cool. Let's learn some new stuff, everybody. Alright, so the code on the screen is the car code that we wrote together last week. Again, to remind us what that looks like, it's just a car. We also have this other little crappy car right here next to our other car. And the key problem that we're trying to solve right now is that we want to be able to make a bunch of cars on our screen without having to copy and paste a bunch of code. So one thing that I'm not really enforcing right now, but it's going to become a bigger deal the deeper we get into code, is that you really don't ever want to copy and paste code. There's two reasons for this. One, from a learning standpoint, if you're not actually typing out the code, you're just not learning it as well. There's like a lot of muscle memory to actually typing out code, and it'll help you sort of get into the habit of remembering how to like have semicolons and stuff. Chris, like, do I sound robotic as in like it's hard? Is it hard to hear me? Or do I just sound like I'm a emotionless person? Because I am an emotionless person. Uh, can everybody hear me okay? Since no one is answering the question of whether or not they can hear me okay, I'm gonna just hope it's okay, and just keep going. If it's a problem, I can try to put closed captioning on later. I sound like auto-tune? That's kind of cool. Let me check out what's going on in OBS. What are you doing, audio capture? Weird. Yeah, I don't know what's up with that. I don't know. If it's a problem when I go back to, if it's a problem when I go back to edit this or anything, I can put closed captions on it if it's too hard to read or hear. Alright. So in our code, we have a core problem here, and that's we need to make our cars but not copy and paste. Maybe if I turn it down, it looks like I'm getting a little loud. Turn it down a little. Hopefully that helps. This sounds like we're in the future. Cool. Okay. Uh, Maybe it'll make coding seem cooler. Okay, so if you are copying and pasting in your code, it's generally like not a good idea. As I said a second ago, you really need the muscle memory of typing it out. Two, if you're copying and pasting, you're probably going to end up with some bugs because you'll forget to change something. And if you forget to change something, you'll have weird situations where something's not in the right position, something's not behaving the way it needs to. So what we want to do instead is actually type stuff out. But in this case, typing out all this code to just keep drawing stupid cars is a pain. It's really tedious, and it seems like annoying. So what we need is a way to make it easier for us to have basically like a recipe to keep creating cars so we can make a bunch of them. So what we need is what's called a function. Uh, this is a new this is kind of a new concept for us, sort of. So thus far in class, I'm going to delete my other car, so we just have the one. Uh, Thus far in class, we've been using functions all the time. Setup is a function, draw is a function, but background, no stroke, fill, rect, ellipse, size, those are all functions. So even though this is like new to us this week, we actually have been using them the whole time. So this is going to be like our vocabulary word that we're going to have to define together in class next week when we're on Blackboard. So what we're learning right now is functions. And functions are like recipes for code. It's code we can use over and over again to do similar actions with slight differences. So processing and a lot of other engines or libraries are going to have a bunch of functions for you that do something that actually behind the scenes is pretty complicated, but they make it easy on our end so we can start doing what we want to. So something like rect is a function, a recipe to draw a rectangle. behind the scenes in the processing library, there's actually a bunch of code that it's doing to tell your computer to render a to render a rectangle to the screen. But on our end, all we have to do is give it these 4 numbers to tell it where to put the rectangle and how big the rectangle should be. And we can reuse this function over and over and over again, so we can create just like a ton of rectangles of different sizes and at different positions. So you can see how it's convenient. For something like functions when it comes to an engine or a library, because it's like all the code is pre-written for us, so we just can write our own code and do cool stuff. But sometimes you actually want to create your own functions because you want to do something over and over and over again that processing doesn't innately do. So in this case, processing doesn't innately draw cars. There is no draw car function. We have to make our own draw car function. So we have to make our own recipe for exactly how to do that. So we are able to create our own function that has its own name. Visually, it's going to look kind of similar to what we're doing with void draw and void setup. As I said, those are functions too. The difference between a function like setup or draw is that these functions allow us to put our own custom code inside of it, and the function itself calls or runs at a particular time. So setup runs at the very beginning of the program, and draw runs over and over again forever. So it'll kind of look similar, the way I'm going to type this, to setup and draw, but it's a little different. So I'm going to start creating like the recipe card for our make car function. So I'm going to say void make car. And then I'm going to put 2 parentheses, an open curly bracket, some space, and then a closing curly bracket. We just started a function. We just created our own. This void part, this should look similar to what we have with draw and setup. You don't need to worry too much about what this means right now. If you're curious, it's called the return type of the function. We might talk more about this in the future. But for now, when you're making your homework or you're writing functions in the future, just know that you have to have this void. Then you give it a name. Just like with variables, we can name our function whatever we want. In this case, I'm naming it make car because it's descriptive. It's what we're calling. That's like what we're doing. We want our function to be named something so we can understand it. But it can be whatever we want. I could call it, I don't know, like Hades is cool. I guess like Hades is cool. I could make it like I love Civ. I could make it coding is fun. That's us, because this is our custom function. We're going to keep it as make car, because like I said, this is how we know what our function does. Just like how if you were like writing out a recipe to make a cake, you would write at the top like chocolate cake recipe. This is the name of our recipe, make car. Visually, what I want to point out that might help you understand that make car, our custom function, is different from draw and setup, is that setup and draw by default when you type them out in processing are going to be blue and they're going to be like bolded. That lets you in on the fact that these are built-in functions that processing has that are going to run at a specific time. Whereas make car is not bolded and it's not blue. That's letting us know that this is something we wrote. So we have our make car function. So similar to what we do with draw and setup though, is we put the code that we want to run for make car inside of our curly brackets. Our curly brackets encapsulate or contain all of our custom code. It all goes inside of here. We can't put it outside, we can't put it above, it's all going to go in here, or else we're going to start getting errors. So in this one case, I'm going to go ahead and copy and paste. I'm going to copy lines 10 through 17, so I'll select them all, actually just cut it, and then I'm going to paste. I'm going to make sure that I go back here so it's all nice and organized. Now all of my code inside of make car is what I need to draw my one car. So I'm going to press play, and let's we'll pretend it's like Dora the Explorer. I'm Dora, and I'm going to ask you a question and like try to think of the answer in your brain and like shout it at the TV. So what do you think is going to happen now that I've copied my code from draw and put it inside of my make car function? What do you think is going to happen when I press play? Let's find out. I'm going to press play. And I have a white screen. My car is totally gone. But that's weird because I have all of my car code right here. I can clearly see I've written it out. Why isn't the computer reading it? The reason the computer isn't reading it is because we haven't told it to read it. Again, computers are very dumb and they take things very literally. We wrote out the code for our recipe for a car. We wrote out our recipe card, but we never told the computer, okay, now make the car. We never handed it the recipe card and said, here's the instructions for making a car. Do that. Do all the stuff in here. What we did here by writing our function, by setting it up, is really just like prepared it. We wrote the instructions out, but we still have to tell the computer to do it, and we have to tell it when to do it. So step 1 to making a function, write the function out. Function out in a way like this. Void function name, parentheses, opening curly bracket, closing not question mark, closing curly bracket, and then code you want to run here. So we wrote our function out. What we need to do next is step 2, call the function. This is going to be another vocabulary word that I'm going to ask us to define together next week. Call and function. So what I mean by calling a function is to run it. It's to write a line to tell the computer to do that code. So that's what this name is for. So we are going to use our custom written function in a way that's pretty similar to how we've used functions throughout the class already. So I'm going to say make car, open parentheses, close parentheses, semicolon. Here on line 13, by typing out the function's name and these parentheses and then ending it with a semicolon, it's like giving the computer a command, telling it like, make a car. Now you're going to run these instructions to make the car. So what do we think is going to happen now? We are in setup. We call our function make car. Let's find out. I'll press play. And nothing is happening. Why isn't anything happening? I'll let you think about it for a second. It has something to do with the code order of setup and draw. We went through this whole thing this morning of me like writing out all those boxes of like when setup runs, when draw runs, when our variables at the top are created. It has to do with that because I'm trying to run make car inside of setup, which runs first, and it runs one time. Then inside of draw, I have this line, background 255, or make my background white. What the computer is doing, it's like first, it says, okay, I'll make a window at the size of 500, 500, then I'll make a car, and then when I have this draw line, that's the next thing it reads, and then it just blanks out the screen. I can't see my car anymore. So I'm going to take this out of setup and put it in draw after background. Peter just compared it to like making a pizza but not putting it in the oven. I really like that metaphor. Yeah, calling a function is like putting it in the oven. You can put all the ingredients together, right? You can make all the dough, you can put the sauce and the cheese and all the fixings on it, but if I don't put it in the oven, it's not a pizza, it's just a gross salad. I need to put it in the oven so we can actually have it. So I've done the equivalent here. I've put it in the oven. I put it inside a draw. I've called it. So I'll press play. And now I have my car again, and I have my car visible with that white background. Really want to stress this. This is like a blueprint for us to make a car. And we could do anything in a function. A function can contain whatever you want it to be. In the future, when we start making games or more interactive stuff, we'll find other kinds of functions that we can use. Yeah, I know chat is delayed, Peter. You probably sent that like 2 minutes ago. I think it's because I'm streaming in too high a res, and that's also why maybe I sound weird. I might have to fix that. But it's okay. I think I know what you're referring to when you say things in chat. Hopefully, if I say something wrong though, correct me. So make cars our recipe. So we know now that like that's how you write a function. Then you have to call a function. But the problem here is that the reason we're learning functions at all is, like I told you, is if we want to make a bunch of cars on our screen, how do we change any of these values, right? Like the core idea of what I want to do here is draw a car at 0, 0 and draw a car at 200, 200. I want to have cars all over the screen, but I don't want to have to copy and paste code. But right now, the way my function works is I have all of my car drawing stuff, but they use all these hard-coded numbers. And if I have these hard-coded numbers, I can't change the position. I could go in here and change it. Like I could make this like 100 instead of 80 or whatever, and that would move over parts of my car. But then what was the point of the function, right? Like I could have just done that in draw. A unique part about a function that's really important, and we got to wrap our heads around, is the use of arguments or parameters. So thus far, when we've used pre-made functions in this class that processing has, like background or like rectangle, there are these numbers that go inside of the parentheses next to the name of the function. So the name of the function is rect, has open parentheses, and then it has 4 numbers in it, followed by a closed parentheses, and then a semicolon. Chris, you can't see anything? Can other people? Y'all can see my screen, right? Like I've not just been rambling, have I? Like with a blank screen. I have to wait a little bit because the chat is delayed. Yeah, let me ask in chat maybe.